Hello everyone, and welcome to today's 3SI Insight webinar, Better Evaluations in Less Time, an Inside Look at Val Nav. My name is Kelsey Vescarelli, Marketing Specialist at 3SI Insight, and I am proud to have here with me today SPE Distinguished Lecturer Randy Freeborn. Randy is a petroleum engineer with extensive experience and expertise in both forecasting and type wells. As a research fellow at 3SI Insight, Randy spends his time exploring new technology innovations and then works with our development teams to implement these technological advances into our suite of integrated planning and reserves products. Randy is an SPE and SPEE member and is a frequent keynote speaker at various conferences, workshops, and industry events. With that, I now hand it over to Randy for our webinar.
Well, thank you for your introduction. Today's talk will be about how you can get better evaluations in less time using Value Navigator. The talk will be split into three components. The first component will be how you get better evaluations. The second component will be how you can do this in less time. And the third component will deal with why Value Navigator is the most powerful reserves and evaluation software. So let's start with better evaluations. First, Value Navigator is better by design. It's designed to handle thousands of wells at a time, which is what you need today with unconventional resources, where we deal with so many wells. And it's designed by engineers for engineers. So the software thinks the way we as engineers think. When you're looking for something, it's where you think it should be. We're going to talk in a few more slides about how we can do forecasting very quickly. But in the next few slides, we're going to also talk about type wells and errors in type wells. On this slide, I want to focus on two things that I believe are important to getting better evaluations. First of all, we do full monthly calculations. We don't try to improve the speed of our software by running a few years of monthly and the balance annual. Secondly, our software is extensively tested before it ever hits the market. For each new release, we undergo at least a month of extensive testing that includes about 25,000 standard tests to make sure that we have not broken something when we add new features. We don't want you to be our testers. We just want you to have a good experience with our software. So now let's look at some details on how and why I think we get better evaluations using Value Navigator. I had the honor of being a distinguished lecturer with SPE this past year, and the title of my SPE Distinguished Lecturer talk was 2 Vital Secrets for Building Accurate Type Wells. That talk builds upon 3 papers that are published by the SPE, and those references are below if you wish to do further reading. But the gist of the talk suggested that the way we build type wells by averaging historical data has 3 potential errors. The first error is forecasting from grouped or average data. What I mean by this is when we average all of our production while there's still data to average, we then have to complete our rate time profile. And we complete that from the averaged or grouped data, and that creates an error. The second type of error is something I call survivor bias, or we in industry call survivor bias, and it deals how we handle depleted wells. The third type of error, somewhat like survivor bias, is how we treat wells that run out of production. We time shift our wells so they all start at time 0. And our newer wells don't have enough production to average over the full cycle of all of our wells. How we treat those wells when they run out of production also creates an error. You can read more about these in the technical papers. The second part of the talk deals with how we calculate probabilistic type wells. And the most common method used today is something I call the time slice method. This method is prone to error and results in a P90 type well that's much too low than what it should be, and a P10 that is much too high. In addition, we do not know what the uncertain parameter is in this type well. And so we suggest, or strongly recommend, that you avoid using the time slice method. In its stead, we recommend using something called the aggregation method, a method that was invented at 3ESI Enersite and is now available for your use in Value Navigator. This method models the statistically expected results that you would have from a future drilling program. And because it's probabilistic and because it includes the effects of aggregation, you end up with a reserve uplift associated with drilling multiple wells. So overall, you get better, more accurate type wells when you use Value Navigator. We have studied type wells for 5 or 6 years intensively, and what we've found is that you obtain much better and much more reliable type wells if you average both history and prediction from your wells. We've done numerous hindcasting studies to show this, and you see this in the slide to the right. The blue line represents the type well that we would create using history only, and the red line represents the type well that we would create using both history and forecast when we average our production. You can see that the history forecast deviates from the known data at late time, and it deviates because of those wells that run out of production. Using history and prediction is the standard in Canada, where Value Navigator dominates the market. And it's the standard because to use this approach, you need very quick and good forecasting. And that's available to you in Value Navigator. In addition to using history and forecast, we also recommend that you use a probit or probability plot for quality control. We are looking for a log normal distribution. And so we plot our probit plot that should be a straight line if you have a log normal distribution. When you see wells that do not fit on that straight line, you need to question whether the information for those wells is correct. It may be that your forecast is wrong and needs to be amended, or it may be that you simply have wells that don't belong in this set of data. When we do any type well, and particularly the aggregation method for statistical or percentile-based type wells, we always do the Monte Carlo calculations included in the software. This does not need to be done elsewhere. And when we have our type well built by averaging, we then go through a process of approximating that average data using a series of chained ARPS equations. And that's what you see on this graph, and how closely we can approximate a type well averaging with ARPS equations. The second segment of the talk deals with how we can evaluate in less time. I worked for upwards of 15 years doing acquisition evaluations. And during that time, I learned that we spend approximately 80 to 85% of our evaluation time doing forecasting. And so Value Navigator works to improve your forecasting speed because that's where you have the greatest gain available to you in terms of freeing up your man time. In subsequent slides, I'm going to show you assisted forecasting, how we can skip looking at wells that we don't need to look at, and how we can update our forecasts very quickly. I'm going to focus on the last bullet on this slide. In our last release, we updated our economic calculation engine and have realized a 4 or 5 times speed increase through new algorithms. What used to take us 2.5 hours to calculate 32,000 cases, we now do in less than 30 minutes. Let's look at other ways that you can evaluate in less time. First, we have a world-class assisted forecasting algorithm. This is very useful where you do not have a forecast to start with. For instance, evaluating an acquisition opportunity, looking at competitor activity, scouting for analogs that aren't in your land holding area. And these all are used for making type wells. Does it work? I know what you're thinking. Absolutely not. You've seen auto forecasting or assisted forecasting before, and you'll never touch it again. Well, I think you should look at the auto forecasting in Value Navigator because yes, it does work. About 90% of the wells that we auto forecast will require no change. The other 10% will not get you into trouble, but really need a quick tweak. What we do is world-class. But don't believe me, see for yourself. On the graph to the right, I'm showing a rate cumulative production profile. This would be a straight line if we have an exponential forecast. Also shown on the curve are the dots that we use to do our auto fit. You're seeing one slide. I'm going to show you 19 more. So you're going to see 20 slides in total. While you're looking at these slides, just use your fingers to count how many of the wells you think need to be tweaked. Here we go. I hope you found no more than 2 or 3 wells that you thought really needed tweaking. This chart that you're looking at now is a roll-up. It's a sum of all 20 wells. We use this as a quick check for the auto forecasting so that you can decide whether you need to dive deeper into the wells for tweaking. What we're looking for is to have a smooth trend through the historical data that continues without an abrupt change into the future. When you see that, you have a reasonable expectation that the wells within that forecast are forecast fairly accurately. Now, I said that only 10% of the wells need to be tweaked, but how do you find those? And whether it's auto forecasts or reserves where you've updated and added another year of data, you really want to only work on the wells that you need to work on. And so for that, we have something we call the video player. We need to first set the speed to match your hand-eye coordination. You just saw 20 wells and you had 3/4 of a second per well to judge whether those wells needed to change. And I believe that was enough for you to make that judgment. Let's add another 1/4 second and have 1 second per well to look at wells. That lets you look at 3,600 wells per hour. As you become more experienced, that will increase. I can now look at 2 wells per second or double that speed. So we set the speed, you do this once. We show you 2 sets of graphs from which you can judge which wells need to be tweaked. These graphs can be any 2 graphs, custom or standard, that you need to make that judgment. Then we start the slideshow player by clicking the forward arrow that you see on most video-controlled devices. While the slides are playing, you hold your cursor over this icon that flags the wells. So every time you see a well that needs to be tweaked, you click. And in an hour, you will have identified which wells out of 3,600 you need to change. Our next objective, to save you time, is to allow you to forecast quickly. Our objective is that you should forecast a well in mere seconds. Let's show you how we do this. Here we have a production well, and I would like to change the forecast on that to start somewhat sooner. And I wish to keep the same ARPS equation, in this case exponential. So to keep the same equation, I hold the control button down, and with my mouse, while I'm holding the control button down, I press click. And there's my new forecast. I may not like that forecast. As I look at the well now, I see a trend coming down through here. So perhaps I would like to draw a box around that trend. I use Alt to indicate that I want to solve all 3 ARPS equations and pick the best. And while I'm holding the Alt button down, I click and drag to form the box. When I release the mouse, I have my new forecast. You'll note on the forecast that we have dots for the data that was used to create the forecast. Any data points, which you can tell by a change in the slope, represents a well that was deemed to be a spike and not included in the calculations. Because this is an internal trend, we take this trend and project it forward to current time, and then we raise or lower the rate to line up with the current rates. Perhaps I'd like to start my fit somewhere else. I'll use Alt and click, and there we forecast, and now the computer is telling us this should be a harmonic equation. We know it's harmonic because on the table we show the B value. We're old school. B value used to be called N, and so N or B of 1 is an ARPS harmonic equation. Now, I might also like to fit the GOR. To do that, we would use a draw. Control D starts the draw. I click Control D. I click my mouse to start here, hold the mouse click down, draw out to the end, unclick my mouse. I now have a forecast for GOR. I think you can see that what you can do with this software, with the way we do our forecasting, you can go click, 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 find a couple of alternatives, then say, this is the one I really like, click, and I've done my forecast. In 5 or 6 seconds, you can forecast wells very quickly. To give you an idea of speed, I'm experienced. If I'm forecasting an oil well, forecasting oil, GOR, and water-oil ratio, I can forecast approximately 150 to 180 wells per hour. If you find you have a fit that you don't like and you can't get what you want with clicking, we have hotkeys available for fine-tuning. So now, if we look at this, we've done our auto forecasting. We've found the wells that we don't like the auto forecasts for. We've fixed them. But now what do we do with the wells that have too little data to forecast using declines? And for that, we use type wells. First, we need to create type wells that are representative for wells in our area. And then we need to select which type wells and which target wells we want to use. What I'm looking for this process that we call analog forecasting is type wells that have different shapes. So instead of what you might normally do, where you'd calculate percentile type wells, we would recommend that you group your wells according to B value. And that's what I've done. I've created several type wells with a range of B values. And so to choose which type wells I want to use, I simply click the drop-down box to select the type wells, and I check the type wells I wish to use. You also need to tell which wells have too little production to forecast that you're going to use this method for. And we've done that on the right. We get a list of wells. We can simply click on the folder and it will select all the wells, or we can toggle individual wells on and off. But now we've chosen which wells we want to forecast, which type wells we wish to use. What the program does now is it takes every one of those type wells and plots them on a graph that has your original production well on it. In this chart, it's a little difficult to see the colors, but the real data is this green well here. What the program does is it shifts or aligns every one of your type wells to align with the current data. Your job now as a user is to decide which one of these type wells best fits the data available. I like this purple line, so I would click on the purple line. It will turn bold to show it's selected, or I will click on the row in the data set at the bottom to select that well. Then I will choose or click Apply Forecast. That allows me to identify which reserve category I want to associate with this type well. And I click OK. And there is my forecast for this well. Again, 5 or 6 seconds per well, and you've got your forecasts. We've looked at this methodology and found that it's quite reliable. We've used hindcasting to use this method for wells with anywhere from 1 to 12 months of data, and then look at the next 2 or 3 years to see how well we've done, and found it's very accurate. And so here's an example of doing that. We have our 12 months of data here that we've used to forecast for these wells. The red dots in the future that line up with the blue are the real data. That's the real production rate from these wells. The blue line is the forecast that we would obtain using analog forecasts. Within this time period here, where we have red dots, our forecast is accurate to better than 5%. And in fact, within this period, better than 3%. And that's consistent with our finding in other wells. If we use all of the history available for each of the wells and forecast using all of the history and show the results for these wells, we would obtain the red line, which is accurate for 3 or 4 years to within 5%. But you can see it is deviating at the end. So what is the accuracy for the full life? For these wells, it's accurate to within 22%. If we want an estimate of value, we could discount our production rates and add them up In this case, I've discounted them at 15%. And from a value perspective, our forecast would be accurate to within 7%. This is pretty amazing considering we forecast with anywhere from 1 to 12 months for these wells. We have some other things that we do to help speed up your evaluation process. One is the input copier. I'm showing you a screenshot here. The bold well, the first well, is where you would enter the things that you want to copy. So you would completely fill in your evaluation parameters for that well. And then you would choose on the right-hand side which of those parameters you would like to copy to all of the other wells. Secondly, we have a very powerful spreadsheet import. Spreadsheet import allows you to have multiple tabs or sheets on your spreadsheet, and each sheet can be mapped differently. Here I'm mapping operating costs, and once you've mapped them, and what I mean by mapping is for each column you tell which data is in that column. You can also use something that we call proxies, and this is the most powerful component of this spreadsheet import. So instead of having each line represent data for a real well, we can, instead of using a unique well identifier, use a proxy field. In this case, I've used field. So any well that is in the Eagle Ford field will be assigned oil and gas operating costs that are in this Eagle Ford row. Then you simply click import and you've imported all of your data. The last feature we have to help you speed up your work is something we call data views. This is a pivot style look at all your input data. Pivot style in the sense that you can change what's in rows and what's in columns. But unlike a pivot table, you're not looking at an accumulation of data, you're looking at a single data value. You can customize and save any number of views that you use periodically to check your data. What's powerful is not only can you Q&A your data using this methodology, looking for things that don't fit. When you find something that doesn't fit, you can simply change it on this screen. You don't have to mark and go back into your database and find all the things that need to change. They're there, you change them on the fly, save the changes, and you're ready to go. So why do I think Val Nav is the most powerful software available for you today? Well, part of the answer is all of the things that I've already shown you. But I'm going to talk about 2 or 3 other things that you haven't seen yet. First, Value Navigator not only is a reserve and evaluation tool, it can also be used to steward your operating budget and create your operating budget. It can also be used to steward your capital budget. Value Navigator also comes with maps that can be very useful for you. You can bubble almost any parameter you want, whether it's economic values or input parameters, lengths of wells, size of fractures. Any data that you enter into the software can be bubbled. You can assign colors to any text field, so you can color for operator or year of production or anything else that you find useful. And if you have surface and bottom locations, you can see well sticks joining the bottom hole and surface location to get an idea where your wells are. But the most important part of the mapping is that you can add shape files. Shape files created by your geologist through his GIS system. So now you can see net pay maps, you can see structural events, fractures, faults. These can all be on your map, allowing you to work more in concert with your geologist and to do a better job in your overall evaluation. And finally, I want to talk about security and audit. Value Navigator has advanced security that allows users to be specified in terms of what they can do with the data. So perhaps your reserve administrator is the only person who can change price files or automatic forecasting defaults. And your area engineer is the only engineer that can change forecasts for wells, but other area engineers might be able to look at those forecasts. And anytime anyone makes a change to the data, there is a time recording of who changed what when. These security and audit features allow you to make your reserve and evaluation process SOX compliant. And so with that, I'd like to end the presentation. Thank you for listening in, and I hope you have an opportunity to listen to more of our webinars. No doubt you have some questions, and if you do, please send them by email to info@3esiintersight.com, and we will be in touch with you to answer your questions and maybe start a dialogue. Or if you'd like to learn more about Value Navigator, do the same thing.
Thank you very much, Randy, for taking the time to show us better evaluations in less time. And thank you, everyone, for joining us. We look forward to having you at our next 3SI Insight webinar. Have a fantastic day.